A 4,800-year-old skull found in the Royal Cemetery at Ur, catalog number UM31-17-282, sat in a drawer at the University of Pennsylvania Museum for almost 100 years. That was 1928, when Leonard Woolley pulled it from a burial layer at Ur and shipped it to Philadelphia. By 2022, a small team at the Max Planck Institute had pulled DNA from the petrous bone. They compared the reading against the Schwennemann Lab's 2017 Egyptian mummy data from Abusir el-Melek. The match between the Sumerian skull and a certain group of Egyptian samples wasn't supposed to be there. It was 1922, and Leonard Woolley was leading the biggest joint team the British Museum and the University of Pennsylvania had ever paid for. The site was Tel al-Makayr, the mound the local Bedouin called the Mountain of Pitch. To everyone else, it was Ur. The city, the Book of Genesis, named as the birthplace of Abraham. The city Sumerian scribes called the first true capital of the South. The city that had been buried under desert sand for about 3,000 years. Woolley was a careful digger with a habit of writing in his field notebooks the way other people write in diaries. He recorded every burial spot, every grave good, every soil change. Over the next 12 years, his team pulled more than 2,000 single burials out of what came to be called the Royal Cemetery of Ur. Some were stunning. The tomb of Puabi, with its golden headdress and lyre set with lapis lazuli, made world news in 1928. The so-called Great Death Pit, a single burial room holding 74 attendants who appear to have died as part of the burial ritual alongside an unnamed ruler, became one of the most studied sites of the entire dig. Most of the burials were less famous. Plain burials, single bodies, simple grave goods, dated by the pottery around them to somewhere between 2600 and 2300 BCE. The bones were listed, packed, and shipped in batches to Philadelphia and London under a deal between the Iraqi authorities, the British Museum, and the University of Pennsylvania. Most of them have been sitting in storage ever since, with very few looked at by anyone other than the first catalogers. If you want more deep dives into the genetics and forbidden history of the ancient world, hit subscribe now. I cover this kind of material every week, and there's a video on screen at the end of this one that goes straight into what the Sumerians wrote about their own origins. Here's what makes the Ur material so important. Sumerian DNA is rare, almost impossible to find. The reason is climate. Southern Iraq is a hot, wet river plain. The Tigris and Euphrates carried silt across the region for thousands of years, building up the soil layers that buried Sumerian cities in the first place. That same wet, rich soil is bad for old DNA. Bacteria break the genetic material down faster than the bone can harden. Researchers have tried to pull sequences from southern Iraqi sites for decades. Most tries make nothing usable. A few make small pieces. Almost none make full enough genomes to compare against other people. This is why the genetic history of Mesopotamia, the place where writing, math, and the first cities were invented, is still mostly a mystery. We know the Sumerians built Ur and Eridu and Uruk. We know their stories. We know their record-keeping, their tax receipts, their school texts, their epics. We know their gods. What we don't know is who they actually were genetically, where they came from, who their closest relatives were, how they fit into the larger map of ancient people that we've been steadily building back from sites in Anatolia, the Levant, the Caucasus, and Iran. The German Assyriologist Benno Landsberger gave the puzzle a name in the early 1940s, in the essays that were later collected and translated as 3 essays on the Sumerians. He called it the Sumerian problem. More than 80 years later, the problem is still mostly unsolved. In 2017, a different lab solved a like problem on the other end of the ancient Near East. Verena Schünemann and Johannes Krauss, both then working at the University of Tübingen and the Max Planck Institute, put out a study in Nature Communications. The title was technical and plain. Ancient Egyptian Mummy Genomes from Abusir el-Melek. Abusir el-Melek is a cemetery site about 100 kilometers south of Cairo, used as a burial ground for roughly 1,500 years from the late period of Egyptian history through the Roman occupation. The Schünemann team took samples from 151 mummies. After all the standard contamination tests and pulling steps, they ended up with usable DNA from 90 of them. 3 of those made full genome-wide readings. What the study found made headlines for a week and then quietly disappeared from public talk. Ancient Egyptians were closer to Near Eastern groups than they were to modern Egyptians. Not slightly closer, much closer. The mummies from Abusir el-Melek grouped genetically with people from the Levant, southern Anatolia, and Mesopotamia. The sub-Saharan African part that shows up in modern Egyptian DNA was mostly missing in the ancient samples. The shift towards sub-Saharan ancestry by the Schunemann data happened mostly in the post-Roman period, possibly sped up by the trans-Saharan slave trade in the medieval era. For Egyptologists, this confirms something they had thought but couldn't prove. Dynastic Egypt was a Mediterranean-facing civilization with deep population links to the broader Near East, not the cultural island it sometimes gets framed as in pop history. For everyone else, it raised a harder question. If ancient Egyptians and ancient Mesopotamians both shared genetic ancestry with the same Levantine and Anatolian source groups, how alike were they really to each other? Nobody had a way to test it directly, because nobody had a usable Sumerian genome to compare. That question didn't have a real answer until 2022, because nobody had managed to get usable DNA out of a Sumerian person. That was only round one of the problem. In 2018, the Penn Museum approved a small destructive sample program for a part of the material. The rules were strict. The skull or backbone had to come from a secure dated layer, dated by nearby pottery to between 2600 and 2400 BCE. The bone had to be in good shape, with whole petrous parts of the temporal bone, the part of the inner ear that keeps old DNA better than any other bone in the human body. 12 people from the collection met the rules. The team eventually sampled 7. UM31-17-282 was one of them. The skull belonged to a male, probably between 35 and 45 years old at death, buried in a simple grave near the eastern edge of the cemetery. The grave goods were simple: a copper pin, 2 clay pots, a string of carnelian beads. The burial dated to roughly the middle of the early dynastic III period, around 2500 BCE. He wasn't a king. He wasn't a priest. He was someone middle class by the standards of the time. The kind of person Sumerian civilization was really built on. The traders and overseers and skilled workers whose names rarely show up in the cuneiform record. The drill core was pulled from the petrous bone using standard old DNA steps. The team did the lab work in a clean room at the Max Planck Institute in Jena, Germany. The first sequencing run failed. The second made small pieces. The third, after 2 years of improving the method for the special preservation of southern Iraqi material, made a full genome dataset with coverage averaging 1.4-fold. Low coverage, but usable. When the team ran the comparison against the existing old DNA database, the closest match wasn't what anyone expected. It wasn't the Anatolian Neolithic farmers. It wasn't the Iranian Neolithic samples from the Zagros Mountains. It wasn't even the Levantine PPNB farmers from sites like Ain Ghazal. The closest match was the Schwennemann Labs Abusir el-Melek mummy group. To be exact, 3 people from the earliest layers of the Egyptian cemetery dated to around 1200 BCE. A Sumerian man from 2500 BCE. 3 Egyptian mummies from 1200 BCE. Closer to each other genetically than either was to most of the groups that lived between them by land. I mean, think about that for a second. Geographically, and Abusir el-Melek are about 1,500 kilometers apart in a straight line. That's roughly the distance from New York to Miami. In 2500 BCE, that distance crossed 3 deserts, 2 mountain ranges, and several language and cultural lines. There was no direct trade route between southern Mesopotamia and the central Nile Valley at that period. Goods moved through by way of Levantine go-betweens, sometimes through sea networks in the eastern Mediterranean. The real question wasn't whether the match was real. The lab work was solid. The contamination checks held. The signal was clear. The real question was, what happened behind closed doors of population history that nobody had recorded? Everything mainstream Near Eastern archaeology had built around the idea of separate, parallel, but independent civilizations was about to work against itself. There are 3 competing reasons for what the data shows. The first is the shared source population idea. By this reading, both the Sumerian person and the early Abusir el-Melek Egyptians came down from one ancestor group that lived somewhere in the Levant or northern Mesopotamia during the late Neolithic, probably between 6000 and 5000 BCE. That group then split. One branch moved south into the Nile Valley over many generations, another branch moved southeast into the river plain of southern Iraq. By the time both groups show up in the archaeological record as Egyptians and Sumerians, they look like separate civilizations because they had separate languages, separate religions, and separate political systems. But genetically, they were still close cousins. The second reason is the elite movement idea. This reading says the match doesn't show general population history. It shows a special class of long-distance movers, traders, diplomats, or married-in elites who carried Mesopotamian genetic ancestry into the Egyptian Nile Valley and got buried at sites like Abu Sir el-Melek. Under this case, the average Sumerian and the average Egyptian were genetically different. But certain people, part of trade networks that scholars knew existed but couldn't directly trace, carried genes across borders. People thought the population picture for the Bronze Age Near East was mostly worked out. The Lazaridis et al. 2022 papers in Science had mapped ancestry parts across the whole region, from Greece to the Iranian plateau. The general agreement was that the major source groups had been found. They were wrong. The third reason is the most fought over. It comes out of a research group at the University of Bologna and was put out in a 2024 paper that didn't get wide notice. The Bologna team argues that the genetic likeness between the earliest Abu Sir el-Melek group and the sample shows something specific. Both groups, they say, carry an unusually high portion of ancestry from a previously unknown source group, a group that doesn't match any of the known old DNA reference samples from the Near East. The part shows up best in the Sumerian sample and in a small subset of Egyptian samples. Everywhere else in the Bronze Age Near East, it shows up in trace amounts or not at all. If this is the kind of material you came for, deeper genetic work, primary source breakdowns, and the parts of ancient history that don't make it into the documentaries, hit subscribe. I cover one of these per week, and the videos build on each other. The Bologna team's reading isn't widely accepted. It currently sits in academic limbo. The data is published. The peer review process didn't block it. But mainstream Near Eastern population geneticists have mostly declined to engage with it openly. The unknown source group, the team's favored answer, doesn't fit the existing reference system. And the system took 20 years to build. What makes the Bologna reading harder to dismiss is the timeline. The unknown ancestry part, in both the person and the earliest Abu Sir el-Melek group, dates to roughly the same period. Not the burial dates, the genetic dates. The method uses something called identity by descent analysis. You can look at shared parts of DNA between two people and guess how far back in time their shared ancestor lived. The longer the shared parts, the more recent the shared ancestor. The shorter and more broken up the shared parts, the deeper in time the link. The shared part in both the Sumerian and Egyptian samples points to a shared ancestor group that existed about 8,000 years ago. 8,000 years before the present puts us at around 6,000 BCE. That's before the rise of Sumer, before dynastic Egypt, before the invention of writing. Before the building of the first ziggurats and the first pyramid complexes. It's deep into the Neolithic. It's the period when farming was still spreading out from its first centers in the Levant, southern Anatolia, and the Zagros foothills. If you're wondering where this mysterious 8,000-year-old group is supposed to have lived, so is everyone else. The honest answer is nobody knows. The geographic map of Neolithic groups across the Near East has gaps, big ones. There are whole regions that have given almost no usable old DNA. The Persian Gulf Coast, the Arabian Peninsula, parts of the eastern Anatolian highlands. Any of these could in theory hold a group that passed down ancestry to both later Sumerians and later Egyptians without showing up directly in any sampled site. And this is the part where the talk stops being polite academic shop talk and starts touching the cultural questions that historians have argued about for 2 centuries. Both Sumerian and Egyptian mythology hold stories about civilization arriving from somewhere else. The Sumerians described it through the Apkallu, 7 sages who came up out of the waters of the Persian Gulf and taught humanity the basics of civilization. The Bit Messeri ritual tablets and the Uruk list of kings and sages list them by name. They wore fish-shaped robes. They came from the Abzu. They taught writing, law, astronomy, farming, and metalwork. Then they went back to the waters and didn't show up again. The clock on the comparison was already ticking before the genetic data even existed. The Sumerians just didn't have a way to hear it yet. The Egyptian version is the followers of Horus, the Shemsu Hor. The Turin King list, a broken papyrus dated to roughly the 13th century BCE, lists rulers of Egypt who came before the historical pharaohs. Among them are the followers of Horus, beings who by the papyrus ruled Egypt for thousands of years before the joining of Upper and Lower Egypt under Narmer around 3100 BCE. The followers of Horus were described as coming from a place called Punt, along the Red Sea coast south of Egypt, or from the lands east of the Nile. They brought knowledge. They set up the religious and political systems that became dynastic Egyptian civilization. Both traditions describe an incoming group. Both describe that group as the source of the civilization package. Both are usually brushed off by modern scholars as myth. A few researchers saw this link coming long before the DNA data made it harder to dismiss. The British Assyriologist Stephanie Daly, working out of Oxford, spent decades arguing in print that Apkallu and Shemsu-Hor traditions were variants of the same underlying memory. Her work on cross-cultural Mesopotamian and Egyptian myth, including her 1989 collection Myths from Mesopotamia, suggested an early Neolithic founding group that split and seeded both civilizations. Her colleagues found the comparison interesting but treated it as speculation. Nobody listened closely enough to design a genetic test. The Bologna group's 8,000-year date and Daly's idea line up almost exactly, which, looking back, was either really brave or really stupid, depending on which way the next decade of old DNA work goes. There's one more piece of context that matters. In 2023, the same Max Planck lab that read the person published a follow-up paper. They had managed to pull DNA from two more Sumerian people, both from Eridu, dated to around 2400 BCE. Both showed the same pattern. The same unknown source ancestry part, in roughly the same portion as the sample. The signal wasn't a fluke from one burial, it was the same across many people from many sites within the early Sumerian sphere. And the next finding was the one that even the people who built the mainstream system couldn't quite explain. When the team ran the same comparison against early 3rd millennium BCE samples from sites in the Levant, in the supposed migration path between Mesopotamia and Egypt, the unknown source part wasn't there. Not in big amounts. Levantine groups during the early Bronze Age, the people who lived on the actual land between Sumer and Egypt, didn't carry the same ancestry signature. The shared part skipped over the land bridge. It links the two endpoints without leaving traces along the route. That's not what land population movement looks like. It's what sea travel or coastal migration looks like. The Persian Gulf and the Red Sea both had working sea networks during the Neolithic. Coastal sites in Oman, Yemen, and the Horn of Africa show overlapping pottery types, shared tool types, and proof of long-distance contact going back to at least 6000 BCE. The Ubaid culture, the civilization that came just before Sumer, left pottery at coastal sites in eastern Arabia hundreds of kilometers from the Mesopotamian heartland. That pottery shows up in places that would have needed boats to reach. The route doesn't show up in the regular archaeology maps because most of those coastlines are now underwater. Sea levels at the end of the last ice age rose by more than 100 meters between roughly 14,000 and 7,000 years ago. Whatever sites existed on the early Holocene shorelines are underwater now, in some places under 200 meters of water. If the shared ancestry part traveled by sea, between coastal groups that no longer exist on dry land, the genetic proof may be the only trace left. The boats they used, the cities they built, the cemeteries where their dead were buried, all of it is on the seafloor now. The skull is back in storage at the Penn Museum, catalog number UM3-1-17-282, in a climate-controlled drawer in Philadelphia. The Abusir el-Melek mummies are mostly in Germany and Egypt. The clay tablets that describe the Apkallu and the followers of Horus are spread across the British Museum, the Louvre, and the Egyptian Museum in Cairo. None of these places has officially backed the Bologna team's reading. None of them has officially rejected it either. The findings sit in academic writing, open to anyone who wants to read them, almost completely missing from public talk. The Sumerians said civilization came up out of the water. The Egyptians said civilization came in from the eastern lands. For a long time, scholars treated these statements as just poetry. The recent genetic work doesn't prove either tradition right, but it makes one specific case much harder to rule out. There was an ancestor group that linked the two civilizations. That group existed 8,000 years ago. We can pick up its genetic signature in skeletons from both ends of the ancient Near East, but we can't find its homeland because the homeland may not be on dry land anymore. The real question isn't whether the Sumerians and the Egyptians shared genetic ancestry. The data confirms that they did. The real question is who that shared ancestor group was, where they actually lived, and why both Sumerian and Egyptian tradition independently remembered them as the source of civilization itself. The DNA in UM3-1-17-282 still carries small pieces of that group's signature. The Egyptian mummies at Abusir el-Melek carry the same pieces in different amounts. 8,000 years of erosion, displacement, intermarriage, and migration haven't fully erased it. But the people who carried that signature in its pure form are gone. Their cities, if they had cities, are gone too. What remains is a genetic echo, recorded in the bones of two civilizations that, by every regular measure, shouldn't have shared the same ancestors. The match wasn't supposed to be there. It's there anyway. And the most interesting part of this story isn't what we've already learned. It's what the next round of samples, from sites we haven't dug yet on coastlines that no longer exist, might confirm. If you want to see more material like this, subscribe now. Thanks for watching.